In our previous video, we considered the ions present in the solution. And we realized that in aqueous solution, we have the ions coming from the compound and coming from the water as well. Then we asked ourselves a question, that in such cases, you realize that the negative ions become 2 and the positive ions become 2. When that happens, which of the anions is going to lose electrons? Or which of the anions is going to be discharged? And which of the cations is going to gain electrons? Or which of the cations is going to be discharged? So selective discharge of ions. The ions are there. We have to select one and discharge it at the anode. Select one and discharge it at the cathode. But what are the factors that would determine which of the ions are supposed to be selected at the anode and at the cathode? We are going to talk about 3 of the factors. The first one is the relative position of the ions in the electrochemical series. Remember we said we are going to have positively charged ions, they are going to be the cations. We are going to have negatively charged ions, they are going to be the anions. So for the cations, the lower the ion in the electrochemical series, the more readily or the easier it is for that specific ion to be discharged or for that ion to gain electrons at the cathode. Now we have our electrochemical series for the metals over here. Lithium, potassium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, silver, gold. So imagine we have 2 ions and hydrogen ions at the cathode in our electrolytic cell. Who is going to gain the electrons? The one lower. So iron and hydrogen. Hydrogen is lower than iron. So hydrogen is going to gain the electrons. Iron will have to keep quiet and sit down. So this chart, as we go down, we increase the ability of the metal to undergo reduction. A reduction is what? Gain. So as we come down, it becomes easier for the metal to gain electrons. It's the reason why when iron 2+ is found in solution with hydrogen ions will rather gain the what? Electrons. Do you get it now? What if we have copper 2 ions and hydrogen ions in the solution? Who gains the electrons? Now remember, copper 2 ions will be found beneath hydrogen ions in the electrochemical series. So in this case, copper 2 ions will then have to gain the electrons ahead of hydrogen ions. That is why when we're talking about electrolysis, we said at the cathode, we have a metal gaining electron or electrons, or we have hydrogen ions gaining an electron or electrons. Because sometimes in the solution, the ion that is present with the hydrogen ion could be higher than hydrogen in the electrochemical series. In that case, hydrogen will gain the electrons. It will be discharged. But if the metal is lower than hydrogen, for example, silver rather gain the electrons ahead of hydrogen. Hydrogen will have to sit there and watch silver take the electron. That is for the cations. For the anions, do the same thing. The lower the anion in the electrochemical series, the more readily it would be discharged. Now remember, the anions are the ones that are going to lose the electrons. So if they are lower in their series, they are going to lose the electrons. Now this is the chart for the anion series in the electrochemical series. Fluoride ion, the sulfate ion, the nitrate ion, the chloride ion, bromide, iodide, and the lowest one is the hydroxide ion. So if we have the hydroxide ions with nitrate ions in the solution, obviously hydroxide ion is lower than nitrate ions in the electrochemical series. So hydroxide ions will be discharged, or it will lose electrons instead of the nitrate ions. Imagine we have the chloride ions and the hydroxide ions in solution. Per the electrochemical series, the hydroxyl ions will have to lose electrons. Then the chloride ions will have to what? Sit there and watch. That is how the relative position of the ions in the electrochemical series affects which of the ions will be selected to be discharged at both the cathode and at the anode. Remember, the one lower in the series would be selected, not the one higher in the series. The one lower in the series. And these are the series. And remember, in our previous videos, we talked about a way to memorize this series. And I told you that when we come to electrolysis, you might have to remember them. So if you've forgotten, go and visit that video and learn the simplest way to memorize the electrochemical series of these metals. For the anions, it's simple. Fluoride is the highest, followed by the sulfate ions, the nitrate ions. Then the rest, it becomes the what? The halogens. In their order, as it is in the periodic table. Chloride, bromide, iodide. Then you end it with hydroxide ion. But this is not the only factor that affects which ion will be selected to be discharged. There are other two factors. Let's look at the second factor that affects which of the ions that will be discharged in an electrolytic cell in case the ions are in aqueous solution. The second factor we consider is the relative concentration of the ions in the electrolyte. We've already considered the position of the ions in the electrochemical series, and we've realized that the ones lower in the series are the ones that are supposed to be discharged. But that alone is not enough. The concentration of the ions in the electrolyte also counts. If the concentration of a particular ion is high, it will be selected to be discharged, although that ion might be high in the electrochemical series. What we are saying is, we could have chloride ions and hydroxyl ions at the anode. Per the first factor we looked at, hydroxyl ion is the lowest one, the one which is lower in the series over here. So hydroxide ions are supposed to be discharged. When we have a dilute solution, things will go on as planned. The first factor will hold. The one lower in the series would be discharged. However, if the concentration of the chloride ions is high, then we have a problem. Although hydroxyl ion is lower in the series, the chloride ion with a higher concentration will have to be discharged. So this one is serving as a limitation to the first factor. The first factor will hold only when we have dilute solutions. However, if the solution is concentrated, then the other ion will be selected to be discharged, although that other ion might be high. But even within this factor, there is another limitation. And the other limitation is for the metals, if the metal is higher than iron, the magnesium, the calcium, the sodium, the potassium, the lithium, they are higher than iron in the electrochemical series. For them, even if it is concentrated, still the lower one will be discharged. But if the metal is from iron coming downwards and it has a high concentration, it is the one that will be selected to be discharged, although it might be a bit above hydrogen in the series. That is what this limitation is talking about. We will look at examples later on, don't worry. Now, for the anions too, if the anion is higher than chloride ion, this rule would not hold. So the anions higher than chloride ions, we have the nitrates, we have the sulfates, we have the fluoride ions. For them, even if their solutions are concentrated, they will not be selected to be discharged. But if the ions are chloride or lower than chloride ions, for example, if we have a solution that contains bromide ions and hydroxyl ions, in dilute solution, we know we are going to discharge the hydroxyl ions. However, in concentrated solution, bromide ion is not higher than chloride ion. So this limitation wouldn't affect it. It would rather be discharged instead of the normal hydroxyl ions. So, we have a question over here. We have HCl solution. HCl solution. Now, the ions present in HCl solution are hydrogen ions, chloride ions from the HCl, another hydrogen ions from the water, then hydroxyl ions from the water. These are the ions present. Now, if the HCl solution is dilute, the normal first factor will hold. We ask ourselves, what are the negatively charged ions? We have chloride ions and the hydroxyl ions. So we have the chloride ions and hydroxyl ions. These are the negatively charged ions. They will be attracted to the anode. Who is going to lose the electrons? Since it is dilute, since the solution is dilute, we will look at the electrochemical series of the anions. Which one of them is lower? Obviously, hydroxyl ion is lower. So hydroxyl ion will lose electrons. Chloride ions will sit there aloof. However, if we have concentrated HCl, the anions are still chloride ions and hydroxyl ions. But the thing is, the chloride ions are highly what? Concentrated. So instead of the hydroxyl ions losing the electrons, the concentrated one, the chloride ions, would rather lose the electrons. That is what the second factor is talking about. We have another example here. Dilute sodium sulfate and concentrated sodium sulfate. Let's pick the sodium sulfate. The ions present are sodium ions, sulfate ions. Now, dilute and concentrate, that means they are solutions. So, hydrogen ions from the water, hydroxyl ions from the water. The anode is positively charged, so it will attract the negatively charged ions. The cathode is negatively charged, so it will attract the positively charged ions. So let's look at the cathode, let's look at the anode, and talk about who will be discharged. First, the cathode. So the cathode has two ions, sodium ions, hydrogen ions. So we are first considering dilute sodium sulfate. Dilute sodium sulfate. At the cathode, we have sodium ions, hydrogen ions. According to the electrochemical series, hydrogen ions is way below sodium ions. Therefore, hydrogen ions will be selected at the cathode to receive the electrons. Remember, it's dilute. And I've told you, whenever it is dilute, we just use the first factor, the position alone, to determine who will be what? Discharged at the anode and who will be discharged at the cathode. So at the cathode, we have hydrogen ions. At the anode, we have sulfate ions and hydroxyl ions. It is dilute. So the one lower will be discharged. And the one lower over there is the what? Hydroxyl ion. Do you see it? So whenever we talk about dilute solutions, always think about only one factor, the positions of the ions in the electrochemical series. So the one lower in the series will be discharged. However, when we have concentrated sodium sulfate or concentrated solution, that is where we have what? Limitation. This means that sodium ions are highly concentrated, sulfate ions are highly concentrated. So the ions are still the same, but what we have here is concentrated sodium, concentrated what? Sulfate. Per the second factor, sodium is concentrated over here and should have been selected to be discharged. But there was a limitation here that for metals higher than iron, those metals will not be discharged, even though they might be highly what? Concentrated. So sodium is higher above iron. We know sodium, you are highly concentrated. We should have selected you, but you are higher than iron. So with your position, even if you are concentrated, we cannot select you. We are going to select the what? Hydrogen ions once again. So at the cathode, we have the hydrogen ions. At the anode, we have the sulfate ions and the hydroxyl ions. And we know sulfate ions, you are highly concentrated. We are supposed to select you. But there is a limitation here that you sulfate ions, you are higher than the chloride ion in the electrochemical series. As such, we cannot select you. So at the anode, you will still have our hydroxyl ions. Do you see these two factors? So whenever we are talking about dilute solutions, always think about the first factor, the position of the ions in the electrochemical series. That alone should do. But when we are talking about concentrated solution, please, the concentrations of the ions also come to play. If the cation is higher than iron, then we are still going to maintain our hydrogen as the substance to be what? Discharged. But if it is below iron, for example, any metal below iron, we can think about nickel. And if it is concentrated, then the nickel will be discharged instead of the what? Hydrogen ion, because the nickel has a high concentration. But in this case, it's sodium. Sodium is way high. We are not going to discharge it. And at the anionic side, the anions at the anode, this one is concentrated. It should have been selected. But there was a limitation that it is higher than chloride ion, so it will not be what? Selected. So let's try and see how we can marry these 2 points or these 2 factors, and we will use that one to determine what will be discharged at the anode and the cathode of certain electrolytic reactions. And before we talk about that one, let's talk about our third factor that affects the selective discharge of ions, which is the nature of the electrodes. Remember, in all these two cases, we have been using inert electrodes. So the electrodes are unreactive and they don't partake of the reaction. What if we use a metal that is active, which is reactive? Would they partake of the electrolytic reaction? What will really happen? Our third factor will vividly explain that fact. With the third factor, we consider the nature of the electrode. Now, when inert electrodes, for example, carbon, platinum, are used, the electrolytic reactions would occur independent of the electrode. So the electrode will serve as the entry and the exit points of the electricity and the what? Electrons. Just that. So electrons will enter through one of the electrodes and leave through one of the electrodes. That is what the electrodes will be doing if they are inert. However, when copper or other reactive metals are used as electrodes, the metals are reactive. So they themselves will also partake of the electrolytic reactions. As time goes on, you will see an example of an electrolytic reaction whereby we use a reactive metal as electrode, and we'll see how the reactive metal will partake of the electrolytic reaction. However, at this point, to construct electrolytic cells, there are three questions we always would be asked concerning these electrolytic cells after we build them up. First question: what are the ions present in the electrolytes? If we know the ions present, then we will know which one will move to the anode, which one will move to the what? Cathode. Good. Then the second question: what are the reactions that would occur at the cathode and at the anode? To know which of the reactions will occur at the cathode or the anode, we will need our three factors: the position of the ion in the electrochemical series, relative concentration of the ions in the electrolyte, the nature of the electrode. These three factors are going to decide what the cathodic reaction will be, what the anodic reaction will also be. And lastly, as the reaction proceeds, what happens to the electrolyte itself? Does it vanish? Does it change? Does it remain the same? That is another question we have to ask ourselves. And in our next video, we'll be considering the various electrolytic cells. As we consider them, ask yourself these questions. What are the ions present in the electrolyte? What is the reaction occurring at the cathode? What about the anode? What happens to the electrolyte? Thank you.